Morning students, today we will study the introduction of exercise 5.2. In this we will study about what is differentiability. So next to continuity we have to do the differentiability. So we will study in this chapter in this exercise how both are related. So differentiability, how we will find that the function is differentiable at particular point or not. So let f be a real function. So what is real function? A function which takes whose domain and range both are real. Whose domain and range is real. That function is a real function. Let f be a real function and c be let f be a real function, c be any point in its domain. We having a function and c we are taking any points in its domain. Now we have to find that function is derivable, or we can say that differentiable. The function is derivable, or we can say differentiable at point C. We have to find that function derivative at or differentiable at point C. How we will find out this? Mathematically, there is a way. Mathematically, there is a way that f dash t we denote that the function is derivative at point C. किसी point पे derivative find करें, there is a how we will denote that f dash c is equal to limit x approaches to c fx minus fc upon x minus c. Using this concept, we will check that the function is derivative at point C, differentiable at point C, provided that limit must exist. Limit को exist करना चाहिए. अगर limit exist नहीं करेगा तो we cannot find the derivative. If the limit does not exist, we cannot find the derivative. So what is the criteria through which we come to know that the limit is existing or not? We have to find LHL and RHL. If both the limits are coming same, so we can say that the limit exists. Limit of that function exists. So there in this we will study the concept of left hand derivative as well as right hand derivative. For left hand derivative, limit x tends to c minus fx minus fc upon x minus c. And we are finding the left hand derivative. So put x is equal to c minus h in this. When x approaches to c, then h will approach to 0. When x is approaching to c, then h will approach to 0. And even h tends to 0, c minus h minus fc upon c minus h minus c, which is limit h tends to 0 f c minus h minus fc upon minus h. So for right hand derivative, we are checking the function is derivative at point C. So for this, if left hand derivative and right hand derivative both are coming equal, then we can say that the function is differentiable at point C or derivative at point C. Limit x tends to c plus fx minus fc upon x minus c. Put x is equal to c plus h. If x is approaches to c, so h will approach to 0. Limit h tends to 0, f of c plus h minus fc upon c plus h minus c. Limit h tends to 0, f c plus h minus fc upon h. So therefore function is differentiable at c. Function differentiable at point c if left hand derivative is equals to right hand derivative. So in the questions, if we have to check the differentiability of a function at particular point, we will find out left hand derivative and right hand derivative. Left hand derivative, limit x approaches to c minus fx minus fc upon x minus c should be equals to limit x approaches to c plus fx minus fc upon x minus c, provided that both the limits should exist. So next is meaning of differentiability. What is the meaning of differentiability? For explaining you the meaning of differentiability, I am taking one curve. This is a curve fx. Okay, for different value of x, we will get this curve. This is fx curve. This is y. Now we want to check the differentiability at point C. This is particular point C. We want to check the differentiability. So at this C, the value reaches to fc. C value पर function की value reach हो रही है fc. We can check that this is any function is if we have given any function. तो अगर हम f2 की value we want to find f of 2, then this is 2 square plus 2. Actually this is 6. So similarly, if we want to find the value at c, the value will be f of c. Now h, I am taking a very small quantity tending towards the 0. Small quantity. So the right of c, that is c plus h. There is a point, this let's suppose B point, and this is B point, and the left of C there is A point. The coordinate of this B point on this curve will be C plus H, comma F of C plus H, and the coordinate of A will be C minus H, F of C minus H. I am going to tell you the concept of differentiability, how this differentiability formula comes, what is the meaning of this. So on C, if we are interested to find the value, we are interested to find the function differentiation at point C point पर function का the differentiation हमें find out करना है. For this, first of all, I am taking one point on the left of C and one point on the right of C on this curve. Now join AP and PB. So chord AP, or you can say line AP. The slope you have already studied in class 11 how to find out the slope. y2 minus y1. y2 minus y1 upon x2 minus x1. So this is f of c minus h, f of c upon minus h. This is the slope of AP. Similarly, slope of TP, BP, PB slope, इस TP लाइन का slope क्या होगा? f of c plus h minus f of c upon c plus h minus c. This is f of c plus h minus f of c upon h. Now if you look these two, if you observe these two, if we apply here the limit h tends to 0 and here limit h tends to 0, this is nothing but left hand derivative and this is right hand derivative at point C. ओके, अब अपने को सिंपली इसमें क्या करना है, we have to just reduce the gap. Here we had taken one point C minus H, and there is a gap between C minus H and C. If we reduce the gap, this AP chord length will be reduced. This will come here at point B, and similarly if we reduce the gap, if we are H is a very small quantity tending towards the zero, if we are reducing the gap from both sides, left side and right side, this will represent only a single slope at point P. एक point P का single slope ये आपको देगा. अभी आपको ये क्या दे रहा है? There are two slopes AP and BB, but when we are approaches this H towards the zero को इसको touch करवा रहे हैं, इसका gap को reduce कर रहे हैं, तो it will give a single slope touches at point P. तो इसका मतलब क्या है कि जो tangent, it will give us a slope tangent drawn at this point P, and we know that if any curve there is a point, so this point there is only single tangent possible. एक point पे किसी भी curve पे we had already studied there is only one and one tangent. So the meaning of this differentiability is that if we are finding the differentiation of any function at particular point, there will be only one and only one slope at particular point. अब किसी दूसरे पॉइंट पर फाइंड आउट करना चाहते हैं स्लोप, तो उसके लिए भी उसका डिफरेंशिएशन यूनिक रहेगा. मतलब देयर आर मैनी ऑन दिस कर्व, ये कर्व पे किसी भी पॉइंट पे हम स्लोप फाइंड आउट कर सकते हैं, एंड दैट दे विल गिव डिफरेंट वैल्यूज. इस पॉइंट पर एक ही स्लोप होगा और इस पॉइंट पर भी एक स्लोप होगा, लाइक दिस. व्हेन वी चेंज द पॉइंट, पर्टिकुलर पॉइंट को अगर चेंज करेंगे तो वी विल गेट डिफरेंट स्लोप. बट एक पॉइंट पर वी विल नॉट गेट टू स्लोप्स, एक पॉइंट पर तो एक ही स्लोप होगा. दिस इज द मीनिंग ऑफ डिफरेंशिएबिलिटी. Now conclusion is differentiation of function is slope of tangent drawn at a point. किसी point differentiation, the meaning is this point पे हम differentiation we want to find out actually that is the slope of tangent. Differentiation means slope of tangent drawn at the point on which the function is differentiated. We can understand with the help of curve, with the help of function. So at one point on the curve it will gives one. So as we are changing, we know that the curve there are many points. Curve पे बहुत सारे points possible हैं. So as we are changing the points on the curve, we get different slopes. Now next problem is if a function is differentiable at point C, then it is also continuous at C. So given function is differentiable at C, so limit x approaches to C, fx minus fc upon x minus c is equals to f dash c, provided that x is not equals to c. If the function is differentiable, so we had studied that function is differentiable, then this limit x tends to c, fx minus fc upon x minus c gives you f dash c. अगर फंक्शन c पर डिफरेंशिएबल है, इसी के अंदर लेफ्ट हैंड डेरिवेटिव है और इसी फंक्शन के अंदर राइट हैंड डेरिवेटिव है. सो द थ्योरम इज कोई फंक्शन डिफरेंशिएबल है तो वो कंटीन्यूअस होगा. इसको इमेजिन करो, किसी भी फंक्शन किसी भी कर्व पर हम फंक्शन कह रहे हैं कि डिफरेंशिएबल है मींस हम उस पॉइंट से टेंजेंट ड्रॉ कर सकते हैं. वी कैन इजीली ड्रॉ द टेंजेंट थ्रू दैट पॉइंट. अगर हम किसी भी पॉइंट पर किसी भी कर्व पे अगर कोई पॉइंट से पे इजीली टेंजेंट ड्रॉ कर सकते हैं, टेंजेंट इज कंटीन्यूअस, तो वी कैन से दैट इमेजिन दैट अगर कोई फंक्शन डिफरेंशिएबल है तो कंटीन्यूअस होगा. ओके, तो नाउ चेक मैथमेटिकली हाउ वी कैन प्रूव दिस. सो fx minus fc, we can write fx minus fc upon x minus c multiplied by x minus c. We can multiply and divide x minus c in numerator and denominator. Okay, now taking limits both sides, दोनों तरफ लिमिट अप्लाई करो. लिमिट x approaches to c fx minus fc is equals to limit x approaches to c fx minus fc upon x minus c multiply x minus c. Now the algebra of limits says that this limit will be given to both the functions. So this is limit x approaches to c fx minus fc upon x minus c multiply limit x approaches to c x minus c. Now when you give this limit in this, when you giving the limit in this, then this is c minus c is 0 and 0 multiply by what is this? This is f dash. This is f dash c. So f dash c multiply by 0. This is the whole result is in the right hand side will be equals to 0. So now simply what we can do in this limit x tends to c fx. When you are giving the limit to the constant and the value will be same fc. So hence we have proved that when the function is given that the function is differentiable at point c, so we have proved that that very function is also continuous at point c. When it is given that the function is differentiable, then we have proved that the function is also continuous at c. This is the condition to prove that the function is continuous. Now the reverse case. So from this theorem, one thing is clear that we can write corollary, means remarks or important point, that if function is differentiable, then it will be that then if the function is differentiable at point c, that then function is also continuous at point c. But the reverse may or may not be true. This we will check in the example, and the example is I am telling you that the mod x, this mod x function graph is like this. So we are not able to draw the single tangent for this, because इसके एक tangent हम नहीं draw कर पाएंगे, और there will be two different values for left hand derivative and right hand derivative. There will be two different values, and we know that mod x is a continuous function. This is continuous function. Mod x is continuous everywhere, but not differentiable, and we will check the differentiability of such function in the exercise or in the questions also. I will tell you. So the function is differentiable, then it should be continuous, but the reverse is may or may not. Sometimes it can be differentiable. If the function is continuous, it can be differentiable, but it's not necessary that continuous function always differentiable, but differential is always continuous. Differential जो फंक्शन डिफरेंशिएबल होंगे वो कंटीन्यूअस तो होंगे ही होंगे, बट जो फंक्शन कंटीन्यूअस हैं वो हो भी सकते हैं डिफरेंशिएबल और नहीं भी हो सकते. In this example, we will check the differentiability of this mod x function at x equals to 0. So mod x function, we know that there are definitions are x greater than equals to 0. This is positive x, and for x less than 0, this function is negative x. Now the formula for mathematically we can write in terms of limit how we differentiate the function f dash t is equals to limit x tends to c fx minus fc upon x minus c. Through this we can find the left hand derivative as well as right hand derivative. So now left hand derivative x approaches to c minus same function. Just now we will put x equals to c minus h and we will keep this h tends to 0. So h tends to 0, f of c minus h minus fc upon c minus h minus c. Now we are checking at 0. So this is limit h tends to 0, f of 0 minus h, f of 0 upon minus h. We are checking the differentiation, means differentiability of this mod x function at x equals to 0. So the value of c will be 0. So now f of 0 minus h, and f of 0 is 0, but the value is 0 because for 0 the function is x. The function fx is equal to x at x equals to 0. So this will be 0. Now for 0 minus h, the function is minus x. The function is minus x, or we can say that f of 0 minus h, this is the function. Fx is equals to minus x when x is less than 0. So f of minus h is equals to minus minus plus h. So this is h upon minus. Understand this again. Again understand this. This is the left hand derivative. So at the place of c I had put 0, 0 minus h, and this is 0. So function की 0 पर value 0 पर we are checking the function on 0 greater than 0 less than 0. So at 0 the function is x. This is the function. So at 0 means f of 0 is simply 0. So f of 0 is simply 0. Now less than 0, less than function के लिए definition है. So less than 0 के लिए minus x is the function. So fx is equal to minus x for less than 0. Less than 0 means this is the function. So we are checking 0 minus h. 0 से थोड़ा सा कम, slightly कम we are checking. So we will use this definition. 0 minus h and minus plus h. So this is h upon minus h, and simply we can write minus 1. So left hand derivative is coming minus 1. Now we have to check right hand derivative. Now we will check that if the left hand derivative and right hand derivative will come same, then we can say that this mod x function is differentiable at 0. Okay, so now right hand derivative. So c plus same left hand derivative is equals to minus 1. Get find out. Now limit h tends to 0. This is c plus h minus c plus h. So simply limit h tends to 0, f of c plus h minus fc upon h. Now f of c means f of 0 is 0. F of 0 is, this is f of 0 and this is 0 plus h. Limit h approaches to 0. Now f of h. We will firstly take fx is equals to x when x is greater than 0. Now f of h is also h. F of h is h. We are checking right hand derivative means 0 is slightly greater than. So f of h is h, and f of 0 is 0, and this is h tends to 0. This is limit h tends to 0, and this is h upon h is 1, and limit h tends to 0, 1 is equals to 1. So in this way our right hand derivative is coming positive 1. Left hand derivative clearly not equals to right hand derivative. It means the given function mod x is not differentiable at x equals to 0. 0 पर differentiable नहीं है, and also but mod x is continuous everywhere. We know that mod x function is continuous everywhere, but here we have seen that that this mod x function is not differentiable at x equals to 0. So in this way, if all the functions which are continuous, it's not true that they may or they may not be differentiable. वो हो भी सकते हैं और नहीं हो सकते. So this is the example. So students, now we will study the differentiation formulas. As you have already seen that differentiation is denoted by d by dx of any function. It can be y or any function. Or generally we take the function fx, so we can also represent f dash x as derivative. Okay, so now as some functions I had categorized, and you have to remember the differentiation. You have to remember the differentiation. So algebraic function x raised to the power n. So whenever there is something like x square, the function is fx equals to x square, and you have to differentiate this with respect to x. So what will come? The power, whatever power that will come outside, and one power is reduced. One power is subtracted. Means here power was 2, the 2 minus 1, so answer will be 2x. So the f dash x will be this function x square will be derivative as the derivative of this x square function will be 2x. Whenever the algebraic function x and there is any power, so that power will come outside and the one power will be reduced. Similarly, whenever there is simple the function we are differentiating with respect to the same, means x dx upon dx, and then the answer will be 1. And you can also use this property in this, the power is 1, so 1 will come outside and one power will be reduced, so x raised to power 0 is also 1, and this is 1. Now there is a constant and there is no variation. इसमें कोई vary नहीं है. These all there are x, and there is a variation was going on. So there is a constant and no variation is there, and you cannot find a derivative. Derivative means हम किसी को change होगा तभी हम उसका differentiation and derivative find out कर सकते हैं, but there is no change in this, so we cannot find, and the constant का the differentiation will be 0. Now some trigonometric functions, d by dx of sin x. Sin x, the differentiation of sin x is cos x. Cos x is minus sin x. Whenever the function starting from c, trigonometric, especially in case of trigonometric, whenever we are going to find the derivative of the trigonometric function start with c, the minus sign comes. So cos x का derivative will be minus sin x, so sin x का cos x. Similarly, cot x, it is starting from c, so minus sign will come. So cot x, and differentiation of cot x will be minus cos x square x. Now comes the tan x. Differentiation of tan x is sec square x. Sec x differentiation is sec x tan x. Cosec x, it start from c, so minus sign will come. So cosec x differentiation is cosec x cot x. Now comes another category, that is inverse trigonometric function. First one is algebraic function, then trigonometric function, then inverse. So sin inverse x, what is the, as we have studied the inverse trigonometric function chapter, so their derivative we should also understand, we should know that what is the derivative of sin inverse x, and we will try to derivate one or two inverse trigonometric function differentiation. So sin inverse x, differentiation of sin inverse x is 1 upon under root square root of 1 minus x square. Then comes cos inverse x. It starts from c, so minus sign will come, and the same answer, negative 1 upon square root of 1 minus x square. Then d by dx of tan inverse x, and and the tan inverse x का differentiation is 1 upon 1 plus x square. Now comes what is the differentiation of cot inverse x? It starts from c and the same answer will come but negative sign. Sec inverse x. What is the differentiation of sec inverse x? The differentiation of sec inverse x function is 1 upon mod x square root of x square minus 1. Then comes for sec inverse x. It starts from c and whatever the answer in sec inverse x, then the same answer will come but negative sign. Whenever the trigonometric or inverse trigonometric function are starting with c, the negative sign don't forget to put. We have to put the negative sign and you have to remember these differentiation formulas because these will be applicable in the question. Now two more categories are left, I will write. Now the next one is exponential function. Exponential function is of the form a raised to the power x, where a is the constant and x is the variable. The base is constant and the power is variable. So f dash x is equal to d by dx. Now we have to differentiate this function a raised to the power x, and the formula is a raised to the power x. Same function will come and then logarithmic log of a base to the base to this is e. So now the next one is a e raised to the power x. At the place of this a there is e. This is also exponential function e raised to the power x. Same, we will use this formula for differentiating e raised to the power x. At the place of a, just put e. So log e base e. This we will study in when we will in the next exercise. This exponential function and logarithmic function will also come. So we will see the properties of logarithmic. So log e base e is 1. Log e to the base e is 1. So this e raised to the power x का differentiation is what? E raised to the power x. Then after exponential there is a logarithmic function. Logarithmic function is log x and exponential function is a raised to the power x. So logarithmic function differentiation of log x is 1 upon x. We can also represent this fx as f dash x is equal to 1 by x, means log x function का differentiation का होगा 1 upon x. Now next topic is algebra of derivatives. So in this we will learn how we will do the differentiation whenever there are two functions, the multiplication of two functions, addition of two functions, like d upon dx, d by dx of k fx. If the function is k is the constant, if the function is of this form, then how you can shift this function, this constant outside, and then d by dx of this fx. Okay, for example, if you want to differentiate d by dx of 2 sin x, this is the same form. Okay, the function is sin x. But this 2 you can keep outside. Or d by dx of sin x and d by dx of sin x is cos x. Now the next is d by dx of fx plus minus gx. So separately you can do the differentiation, like d by dx of fx plus minus d by dx of gx. What is the meaning of this? Means if there are two functions and you want to do there is addition of two functions and then you have to do the differentiation. Means you can separately differentiate first function, then separately differentiate second function, then you can add the result of both. Similarly in case of subtraction. And the next category is simple product rule, or you can say product or Leibniz rule. So if there are two functions given in the product and we want to differentiate them, so we cannot write that d by dx of fx multiply d by dx of gx. This is something different. So treat this as u function and this as v function. Means we want to differentiate both product of both. This is a symbolic representation how to represent product of two functions, the differentiation of product of two functions. So the technique is first function we can do the differentiate and keep it the same as the second function. Then we will use plus sign. Then first function as it is come same and then differentiate the second function. So this is the rule, product rule, which we can use in the question, and it's very important. There are two functions given and we want to find out the differentiation of the function which are coming in product. So what is the method? We can take an example also. For example, the function is x sin x. This is the actually function, and we want to differentiate the function f dash x. We want to find out. So this is u, this one is v. Both are the functions. So firstly we can differentiate this x and keeping sin x same. So what is the differentiation of x? This is 1 plus. Now this x will come same and the differentiation of sin x. What is the differentiation of sin x? Cos x. So the finally answer will be sin x plus x cos x. Now the last rule is quotient rule. Quotient rule. When the functions are given in divide form, means quotient form में दे रखी है function, or you can say u upon v form, and we want to differentiate such functions which are in divide form, fraction की form में आ रहे हैं. So the method is the denominator function whatever is coming we will square, we will write square, we will do the square, and then as it is v means denominator function will come and we will differentiate the numerator function. Then minus sign will come and then u function as it is will come and then we will write the differentiation of the function which is in the denominator. So this is the formula of differentiating the differentiation which is coming in the form of quotient form. Quotient form में जब function आएगा तो we will use this approach. We will apply this in the questions. Now the next is chain rule. This is very important for doing the differentiation of composite functions. So chain rule is used to differentiate composite functions. So for explaining you this chain rule, I am taking one example, y equals to sin x squared. Like this is the function. So we have to differentiate this now. If this was only sin x, simply the answer is cos x. But here is x squared. Actually this is made up of two functions, sin x and x squared. Composition of these two functions. So firstly we will do the substitution in this. That x square is equals to t. So y is equals to sin t. We have done the substitution. Now we want to there is two ways to do the substitution of this sin t function. We can either differentiate this with respect to x, or we can differentiate this with respect to t. But when we are differentiating this with respect to t, this is simply cos t, sin का क्या हो गया cos t and dt upon dt. This t with respect to t is simply 1. So we can write simply that this is cos t. Now the second means other way is we have to differentiate according with respect to x. So how we can do? Firstly sin का differentiation. What is the differentiation of sin? That is cos. Sin को एक बार cos में लिख दिया, sin t का differentiation cos t. Now the problem is here t. We are differentiating this function with respect to x. इसको x को के जैसे मानते हुए इसको पहले एक बार कर लिया. Now the problem is t. So we will further do the differentiation of this t with respect to x. So dt upon dx value we will find from this. Differentiating both sides with respect to x. This is 2x is equals to dt upon dx. So in here we can write 2x and cos t. T क्या है? T is what? X square. The angle is x square for cos. So finally cos 2x x square. So like this chain rule में अगर हमें इसको x के रिस्पेक्ट में करना है, but the original अगर sin x we had learned how to differentiate sin x, cos x, these trigonometric functions we had been, but we don't know x square. This is not the standard form which we had studied. जो हमने फॉर्मूले अभी रीड आउट किए थे पढ़े हैं उसमें, तो ये x स्क्वायर देखा उसमें x था, तो we have to use chain rule in this, and this is very important concept. Mostly many questions this will be useful. Now another example is sin ax plus b. So simply if we want to differentiate this with respect to x, so firstly without thinking any other thing, इसको भूल लो कि sin का differentiation is simply cos, and now this angle, actually we know that the differentiation of sin x is cos x, but this angle is not x, this is ax plus b, so we have to differentiate this also. ये वाले पार्ट को भी differentiate करना पड़ेगा, तो this is cos ax plus b, and the differentiation of this is d by dx of ax plus d by dx of b. We know that this b is constant. Constant का differentiation is 0, and ax, this is the constant and here is x. So a will come outside and dx upon dx is 1. So the answer of the differentiation of this function with respect to x is a cos ax plus b. This is the final answer, and in many questions we will use this chain rule.